Okay, so for this question, it's like a tree structure. So, for example, if we have four stairs, then we need to calculate three stairs, like how many steps, and two stairs, how many steps. Right, math 1, 2, and math 1, math 2. So we have 4, 3, 2, 1, 4, 3, 0, and 4, 3, 2. So here you should use a recursion. First, you define the recursion. So it's called n, and if n equal to 1, you return 1. So if n equal to 2, so if will return 2, and then you return recursion n minus 1 plus recursion n minus 2, and then you call this recursion you can run this, and we can see this one I think will pass several cases at least. Okay, the time limit exit. So for the test case, we have several different test cases, and so the first 1, 2, 3 they all passed, but this one it has time limit. So where we have to use dynamic programming. So dynamic programming is what? So let's draw this picture, like how to optimize this. So 4, if I minus 1, minus 2, we get 3, 2, and we get 1, 2, and we get 1 and 2. Oh no, 2 and 1, right? And then this part we get 2. So 2 is already no. 2. Okay, 2 already know. This is not a good case. So let's use a more complicated case. So we have 6, and then we get a 5 and what? And 5 and 4. And we get a 4 and 3. We get 3 and 2. So once I calculate a 4, I know here is already a 4. So we don't calculate it anymore because I already know 4 is there. So to optimize it, so this one we don't let them reach to the end. Instead, we need a table to store it. Usually, the table will be a dictionary to store the best case. For example, I have 1, which is value 1, and 2 is value 2. So to modify this, we just first to set the best case. So if n not in table, if n is not in table, then we need to create a new table by using recursion. So the table will n will equal to table n minus 1, alright, and table n minus 2, alright. And so we need to put that into recursion. So here we use the table. So here we just do a recursion call of the table minus 1 and n. So we should like this. Table. Okay, we assign new table, and at the end we return the table n. So this is the recursion, and we call this recursion. Let's try this. Okay, so recursion missing one table, so we just added the table to there. and the integer is not iterable, so the table here is the integer. If n not in table, let's print the type table. It's a dictionary, but I don't know why it's an integer. So we have 2. Table n. Okay, so we don't need to return table 1, we just need return what? Table n. Because I already assigned the value to there. So why the type is the integer? Why the type is integer? So 2 and 1. Table. And its value is 2. Why is an integer? Three. Table. Minus 1. Minus 1, yeah, I should use n minus 1 and n minus 2. 3 n minus 2. Oh, the table can't be this. Okay. So this is the final answer, which can pass everything. So this is the dynamic programming. This is the one way to write just add a table to it. And there's another way to write a dynamic programming. Let's check the answer from here. We can have the tupulation, which is using a for loop or while loop. So you initialize a table with the length of elements, and then you assign the first two one, and in the second we fill the table with the previous one, and then return the current table. So this one has a better also have the better runtime. So this is it says easy, but it's actually tricky because you need to use dynamic programming to finish this problem. So this is easy in dynamic programming, but dynamic programming itself is a little bit a tricky concept. So we have to remember how to add dynamic programming into recursion.